All right, welcome back. We are COMP301, that's Linux operating systems in the summer 2020 semester, and it's week 9, part 2 of our broadcast. We're going to talk a little bit about, like a tiny little bit, about data science. I think this is like, for me to say we're doing data science is like really not really, but more like static visualizations. We're not really doing much of a simulation, we're just doing some more die rolls today. But we're going to take those die rolls in a very short way and put them into some kind of bar plot graph thing that we're going to make. Okay, very easy, nothing too crazy. Okay, so, and then hopefully there might be an assignment. The next assignment we do, if we do another one, there'll be another assignment that's more, that might use more of, some more plotting, some more stuff I want you to do, just to show me that you know how to do a bar graph or something like that. Okay, we'll see how it goes. All right, so what are we doing today? First of all, we're going to install Pip. We did it kind of last day, but I really ran through it quickly because I was running out of time and I wanted to tell you, kind of what to do. Matplotlib and Seabourn. Seabourn is kind of built on top of Matplotlib, and then we'll build a little bar graph. That's all we're going to do today. Nothing too crazy, but this will take some time to do. So really, we talked about descriptive statistics last time, things like mean, median, and mode. We know how to get things like min and max, those kind of things. Those are part of descriptive statistics. And the other things we haven't really covered are things like, the kind of percentages. If I want to get, different quartiles, for example, the 25th quartile, the 50th quartile, the 75th quartile, and all that kind of stuff. This is just parts of when we start analyzing a data set, as an example, right? We want to look at all those descriptive statistics and get some information back. It gives us some information about where things are, and the great thing is we want to be able to plot those things and visualize them, because seeing numbers doesn't really tell a story, but actually seeing the graph, that really sells it to people for sure, right? So we're going to use two open source visualization libraries, Seaborn and Matplotlib today, and we're going to display a static bar chart. That's what we're going to do, showing some final results of this die rolling simulation we're going to make today. Something very, very simple. Seaborn is based on Matplotlib, so it's like Matplotlib is required for Seaborn to be installed. Seaborn will do it all for you, but I'm going to do it one step at a time. And then we'll use both libraries in one way or another. So this is kind of what Seabourn can do for us. It can make a little bar chart that looks like this, right? So with some interesting information, right? So things like, each of the different distributions, that's what this is, of the die. If I roll a d6, a 6-sided die, a bunch of different times, as we go, we're going to get a distribution of probabilities that land in different buckets. For example, how many times 1 was rolled, how many times 2 was rolled, how many times 3, and so on, right? And notice that there is an uneven distribution, and this is because of the number of rolls that we make. Let's say we only roll 600 times. And also remember that we're doing pseudo random numbers. We're not really doing random numbers. We're simulating what it would be like to do random numbers. Actually, that's the same in all computers, really. At the end of the day, we might get a distribution of random numbers that we use, whether it's in video games or in simulations, to make it more interesting, and really pseudo-random numbers. Okay, so again, we figure out that each die should have about 100 occurrences, right? So when we look at this, it should be like 100, an even distribution, right? Because if I roll one 6-sided die, there's this equal number of chances for it to fall on 1, 2, 3, 4, 5, or 6. There is no higher chances. Like, it's not like the die is not going to be shaved on one side. Most 6-sided dies are even, right? Are pretty much the same, unless you go to some place where they're going to try and cheat you or something. So, we roll one 6-sided die, you're going to get the same chances to get a 1 or a 6. It doesn't really matter, right? But the reason why we get this distribution is because of the pseudo-random numbers. So it's not a large number of rolls, right? 600 rolls. But as we go forward, and let's say we do 60,000 die rolls, right? Then we're going to get closer to 100 or the equal distribution. And as we get into 6 million die rolls, right, they'll almost appear exactly the same. And the reason for this is because of this idea of the law of large numbers. The law of large numbers basically says that the larger the numbers are, then the more reasonable and accurate kind of your distribution becomes, right? So we can get a sample of a distribution of numbers based on, let's say, even something as small as 30. That basically tells us with the sample we can get an idea of the population, right? So a good example is if I'm giving and we're going to talk about this maybe another day, but if I'm going to do a survey, for all Canadians, the larger the number that I get, then the more accurate the results are going to be for the percentage of Canadians that feel a certain way. As an example, let's say if I ask a survey like, hey Canada, right now with COVID-19, how do you feel about sending your kids back to school? That could be a survey. And if I send out, the survey, not everyone is going to answer the survey. There's going to be a large number of people that are going to answer it now because of the interest. But in regular times, if I ask that kind of question, how many, how do you feel about sending your kids back to school if there was some kind of pandemic or something? You might get a different response than we have now, right? We might get less people answering. So we can get a sample. We can use a sample size. Let's say, for example, we send the survey in not all households, or we don't expect it back from all households. And that sample size is going to be representative of the population, right? And the reason why this happens is because of this idea of the law of large numbers. We'll talk about that later. What we want to do is we want to graph this, we're going to roll, this 6-sided die a bunch of times. And the one thing that this graph does is it gives us this die value for the x-axis. So if you look at the x-axis, there's die value. It kind of puts that in there, like that actual label, right? It gives us frequency for the y-axis. So it kind of puts the frequency up there. This is like what Seabourn will do for us, right? This little library we're going to use, right? The text above each bar representing the frequency and percentage of the rolls. So frequency, how many times things were, like a tally of how many rolls, and then percentage based on the total 100%. As an example, it should be with six dice, or 6 pips, if you will, one for each face of the die, an equal distribution of 16.66666%. But of course, it's not. Okay. And the bar colors. The bar colors are going to be kind of associated randomly, I guess it would be, according to how many there are. The more colors, the more bar colors you have, the more Seabourn will kind of pick some colors for you. Okay, that's what it does. All right, so we'll use some default options for the stuff that we're doing today. So we're not going to do too many tweaks. We're going to start by some defaults, and then we're going to add some code to make sure that things work a certain way. And you can see there's a couple of additional examples here. So here is what happens. Remember we talked about the distribution. This is the distribution for 600 die rolls. Well, here's the distribution for 60,000 die rolls is a cutout. And here's a capture of 6 million die rolls. See how it looks almost equal, right? And again, law of large numbers will make it so that the distributions would fall roughly the same. Okay? So just giving you that example. So there's still some variation here in 60,000 die rolls, but as we get larger and larger, then distribution starts petering off and becoming equal. All right, so now let's get to it. So we want to install some required packages for us to do this work today, and we're going to do it inside of our VM. So I'm going to bring up the VM. Here we are. So I'm going to log in here. So I would ask you to bring up your VM at this point, right? No, I'm not going to update anything right now. Remind me later. Okay. So let's do some installations here together. And hopefully you guys are with me. Are you guys with me? Do you guys have your VM up? Because I want you to do this. There's probably going to be some stuff I'm going to ask you to do with this stuff. Okay. Thank you, Tiago. But if you're not with me, then what's going to end up happening is that later on when I try and do this, you're going to have to watch the video and install this stuff, and it's a waste of your time. Let's just do it together now. All right, so let's see it. So I'm going to bring up my terminal. Hopefully you guys have this up. I only saw one check mark. Is there anyone else that's with me, or is it just Tiago? Because I can wait a little longer. Otherwise, okay. Baisel. Anna Root. I see some other people. Steve, thank you. Because guys, I'm gonna do this now, and then it's something that you're gonna want to know how to do. All right. I mean, it's not a big step, but thank you for that, guys. But I'm going to start doing this now. So the first thing is we get into our VM, we launch a terminal, and then I'm just going to follow the PowerPoint here. So I'm going to switch back and forth. So you can see that we want to install pip for Python 3. So Ubuntu ships with Python 3, like we talked about before. You know, it's the default Python installation. It doesn't install Python 2 or anything like that. And what we want to do is we want to install pip, which is the package manager for Python. Okay, that's what it is. So it's like npm for Node, as an example. Here, what we're going to do is we're going to do a Pseudo Apt update, which is going to update our package list. So we're going to do that first. So sudo, even if you've done it before, apt update. It's going to ask you to log in, and it's going to just update all the packages. You can see even me, I have some packages I have to update as an example. And it also says 79 packages can be upgraded, run apt list upgradable to see them. Okay, we can do that. So apt list upgradable. You may not have this. Okay. So again, it listed a bunch of packages that it recommends that, you know, these are all things that we can upgrade. I'm not going to do this now. This is going to take a little bit of time to do, and it's going to put my VM out of service for a bit because some of these things are Ubuntu and system specific, so we're not going to do this now. But you can see when I did this, it kind of pulled up an upgrade. And even in the beginning when we started this thing, it said, hey, by the way, you have an upgrade. What do you think? So let's go back to the PowerPoint. So we updated, we used Pseudo Apt update, and now we're going to use Pseudo Apt install Python 3-pip. You can actually copy paste from the PowerPoint. And by the way, this PowerPoint lesson 09b PowerPoint is up on your Centennial, eCentennial here. I've put that up today, lesson 9b, right? So if you're following along, just copy paste from that, and we should be good. All right, so I'm just going to grab this line here. I'm going to copy it, and hopefully it'll allow me to paste it in my VM. So I don't have to put this in. So right click and paste. And you can see that I've already done this. So it's going to say sudo apt install python 3-pip. I already have it, so it's going to be there. And what you want to do here is you want to do a pip -- version. And what this will do is tell you the version of pip that you've installed. Mine is 20.1.1 as of this recording. So there might be something else you guys have for yourself. So hopefully you guys are ready to go. Are you with me? Do we have? By the way, if you're not using Ubuntu, then apt won't be available. You remember you're going to have to use our other DNF command to do the same thing. So for people who are not using Ubuntu, thank you for that, Tiago. Then how do you install pip installation for Fedora, right? Because pip installation for Fedora is very similar, right? So if you look here, there's going to be instead of yum, you can use DNF. DNF install python-pip. Python 3.pip most likely will do it. Okay, so DNF. This is the old one. Yum is the old version for Fedora 21. That's pretty old. Here's Fedora 23. Let's take a look and see what that looks like. There it is. DNF -y. -y says, suggest, add everything. Update will update your packages, just like I just did. And then DNF -y install python-pip will install the latest version of pip for Python. Okay, so do that. Yarn, yeah. No, Yarn will do it in a different way. So just, like I said, try and do DNF for yourself. If you're not using Ubuntu like I am and you're using Fedora, then you'd want to do it this way. Okay. All right, so hopefully you guys are with me. Let's see who's with me. Put a check mark, please, because we need to know that you've done this part. If you haven't installed pip, you can't move on. Wait, X if you're not ready. Tiago, is that a hand that you're ready, or is that, do you have a question, or are you good? Oh, wait. Okay, I'll wait. No problem. I know I'm a little faster, and again, thanks, Steve. I'll leave your check marks up there, guys. If you've done, please put a check mark next to your name, so I can see that you're ready to go. For those people who joined late, like I said, we're going to do a little bit of visualization today, and for that we need to install our package manager for Python, Pip. So when you're done, please put a check mark, indicate a check mark next to your name to let me know that you've done your installation. What we're doing is Pseudo Apt install if you're using Ubuntu, or if you're using Fedora, you can use dnf-y update first, and then dnf-y install python-pip. And what this will do is install the package manager for Python for us. Okay, so please, let's get that done if you haven't had a chance to already. I'm going to wait a little longer, guys. We need to get this done, or else we won't be able to continue, or I will, but then what's going to end up happening is that you're going to be in trouble. And let me just make sure pip3, when we put install, I want to make sure that I give you the right commands, because I think pip3, you have to put pip3 in there. Fedora, Python 3 on Fedora, super user, yeah. I think it's the same. Just want to make sure that you guys are good. No, you'd have to go Python 3 pip, same thing, like I said earlier. Like apt-get, you'd use a Python 3 pip, not Python pip. So that's probably going to install. It'll tell you, it'll probably complain if you use Python pip, because we don't have Python pip. Alright, so hopefully you're with me now. I don't see a lot of check marks, guys. Are you still installing? I see Tiago, I see Steve, I see Anirudh. I don't see the rest of you guys. Are you following along? Are you going to do it with me? What's happening? Shankar, thank you. Anyone else? Python-pip, Python 3-pip. So it's Python 3-pip, not Python 3 space pip. Try it again. It should work pretty quick for you. Joseph, you almost there? Good. See, I was just asking, and there you go. You put up a check mark. That's good. Nushig, how we doing? I'm waiting for everybody a little bit longer, only because I want to make sure everyone's on the same page. And there's only a handful of people here today. We only got like 14 people out of the class, which is unfortunate, but it is what it is. All right, so once we've got pip installed, now we can do the rest of the installations. So I'm just going to clean this up and we'll continue. So what I want to do now is I want to do a pip. We're going to use pip. Let's clear it up so you can see it. Pip install, and then we're going to do matplotlib first. Matplotlib. So matplotlib, and then press enter. And this will do, it'll be the installation. I've already done the installation, so it's going to say requirements already satisfied. But you're going to do it, and it's going to go through, and it's going to install Numpy or Numpy Pillow, which is going to, as an output, Scikit-Learn, Kiwi Solver, and some other things. Okay, so that's what it's going to include. Python date util, a date utility, and pyparsing. Okay, pyparsing. So it does all those things. Those are all the requirements that matplotlib has. So hopefully you've got all that installed. Can I see some check marks for matplotlib, please? I know I'm going slow, but I want to make sure everyone's good with the things I'm asking you to do. Couple check marks, Steve and Tiago and Anirudh, but I don't see a lot more. There's Joseph. Thank you, Joseph. Shankar. Same people that were ready with pip. How about the other people? Did you guys install pip yet? Okay, we'll clear this. Let's do the next one. The next one is Seabourn. All right, so again, I'm just following the example here. So we did Python, pip, we did matplotlib, and now we're going to install Seabourn. And then finally, we're going to install one we're not going to use today, which is Scikit-Learn. Okay, so install Seabourn. So again, clear, pip, install Seabourn, and then press enter. And that'll do everything that that will take care of all the rest of it. Again, it's going to go through and see all the requirements. And if it's already been installed, pip will say, I don't need to do it. It's already requirement already met. But you can see that Seabourn will also try to include Numpy, SciPy, Matplotlib, Pandas. Pandas is really cool. It's a great library. We're going to use that again later on. The date util, PyParsing, Pillows, Cycler, Kiwi Solver, all those things. If you notice, if you just did Seabourn, it would do all that stuff too, right? Because Seabourn depends on Matplotlib. But I'm getting you to install this one step at a time so you can see the steps involved. All right, who's got Seabourn installed? Check marks for yes, and hopefully you guys more than. Got a few more people. Shankar, Steve, Tiago. Still waiting for Seabourn to be installed for the rest of you guys. Hopefully. Some people aren't ready. There's Anirudh. Thank you. Okay, we're going to move on. And the last one is Scikit-Learn. Okay, Scikit-Learn is a machine learning library. We're not going to use that today. So, but we're going to install it anyway. So I'm going to say again, pip install. This time we're going to use the -u option, which is an update option, -u, and then scikit-learn. All right. And if you've done everything right, and if you press enter, then it should give you the installation requirements. And there's another one. There's a couple packages I'm getting you to update. But you notice it depends on Numpy again. It depends on something called threadpool. SciPy, which you already have, joblib, not a few dependencies there that we have to add in, but so you've got a lot of dependencies here already for anything else we add in the future. Okay, so let's see if you guys can get Scikit-Learn, SCI-kit-learn. And Root, thank you. And so what we're doing is we're going through the process. This is kind of what we do when we look at packages. We install a package for Python, and then we can use an import, and that's what we've done. So hopefully you guys have got that ready to go. I'm not going to check marks for this one. All right, so now that we've got that in play, then what we're going to do now is going to step through it. So what we want to do is we want to do this part right here. So we want to install or import this stuff, and I'm going to start a new script inside of our we're going to use Visual Studio Code here, and we're still working with lesson 9. I'm just going to add a new script. Okay, so whenever it decides to launch. So we used main.py as an example, and I'm just going to make another one. I'm going to call this barplot.py. So we'll make another one. Barplot.py. There we go. Barplot.py. For now, we're not going to make it a function. I'm just going to start importing some stuff. I'm just going to follow the PowerPoint's stuff that I've asked you to do, the code. So the first thing we're going to do, this is a good test, we're going to import matplotlib. Notice that it would come up now. As soon as you install matplotlib, it comes up. It'll actually show. Visual Studio Code is nice enough or smart enough to understand that matplotlib pyplot is what we want. Pyplot is kind of a class that we're installing for matplotlib, and we're going to install it as PLT. And that's kind of a very standard way of doing things. So PLT is now the name that we're going to use, the short form or the alias that we're going to use for plot, as opposed to matplotlib.pyplot. We're going to have to do that every single time. It's too much, right? So that's the first one. And then we're going to install Numpy. So Numpy, and we're going to install it as NP. NP is the standard way very a standard convention. I don't like the short forms myself, you know, but this is the way data scientists do it. They usually use PLT for matplotlib.pyplot, and NumPy is usually NP. And then the next thing is we're going to import random. We're not going to change that. And the last one is we're going to import Seabourn, right? You can see that when I do Seabourn, it finds that as well as SNS. And that's SNS is another standard or convention that we use for those libraries. Okay. So hopefully you're with me on those little imports. And again, this is just the beginning of our script. We're using some imports. Okay, and I've spaced them out just like we do that we've done inside the PowerPoint slide. Okay. So now what I want to do is let's do some stuff. So we'll say roles, right? This is a new variable. Roles is equal to kind of a random range, rand range. There it is, right? And the rand range is going to be from 1 to 7. Remember what we did? We did this before. And what random does, right? Rand range, it produces a number between 1 and 6, right? And notice I'm making this, I'm putting it in square brackets, and I'm going to do it all in one. So I'm going to say random from random range for I in range, right, 600. So this is interesting. Well, you can do this, right? And notice I'm inside the square brackets. So remember we talked about Python, easy to learn, hard to master? What is this going to do is it's going to produce a number, a set of values, 600 values here that we can use. And instead of using how we did before, we just did kind of some values that I pulled out of the air last time, like 1, 2, 25, whatever. Here it does it for us. And if we want to, let's print roles and see what we get. And let's try and run Python now. So again, control backtick, and let's try running this. We'll say Python, and I'm going to point at barplot.py, and let's see what we get. And it says can't open the file barplot.py. It says no such file or directory. Am I in the right lesson? It's there, is it not? What? That's weird. Barplot.py is there. Ha! That's a first. Barplot.py. Did I spell it right? Oh yeah, I did. I spelled it wrong. Barplot.py. Barplot. There we go. And you can see the numbers. There's 600 numbers from 1 to 6. All right. And yeah, I know. Thank you, Anna. So you can see that there's like 600 numbers. Hey, and it's inside of a list. It's a list of 600 numbers. That's what this does. So that's interesting. An interesting way of doing this. You know, if I said roles is this, and it put it inside square brackets. Remember, there's 3 things we learned this week. We talked about lists. We talked about tuples. And we also did dictionaries. And square brackets to us mean lists. It means a list, right? So that is, so what we're doing here in one blow is we're saying, hey, generate a number between 1 and 6. That's what this does. So up to 7, but not including 7. And then for I in range of 600 is 1 or 0 to 599. That's what this does. All right. So it kind of does the for loop. We could have written it this differently. For let's say, for example, I wrote a for loop instead, right? And I want to add to this thing. I could have written this in a bunch of lines. I could say for I in range 600, right? This is how normally you would see it. And then you'd say something like roles, you know, and we would have to kind of specify that roles is a, let's just comment this out so it doesn't bother us. We could say that we would say roles is equal to a list, right? Roles is a list, and we can say roles plus equals, because remember we can use plus equals on a list, something that's random.rand range, right, from 1 to 7. And this is the same, these 3 lines right here, roles, and this thing right here, all this from here to here, right, is the same as us doing it in one line. Let me show you that. So if I save this and I do the same thing, I kind of bar plot then it does, well, actually, it says one thing. It says roles plus equal to random range 1 to 7. It says int object is not iterable. Int object. So what am I doing? I'm getting a list of any random.rand range, right? And I want to add it in. Remember, we want to add it into our list. So we could do something that looks like this, right? So now we're adding a little list. Let's try that again. And then we get the same number. All right, so that's what this does. We're saying, hey, get the number of 600 roles. We're getting this, making it a list, adding on to roles, and now roles is all those numbers. So we could certainly do it like this, like how this is looking. But we can do it in one blow, so it looks like this. And it's a different format, different. I'm just going to comment this part out, right? So you can see that this is one way of doing it. So this is one way, or another option. I'll say another way of doing it. Another way. Generating 600 roles. Okay, so that's, and I'll make a little hashtag there, so that way, just in case we undo this again. And let's undo this part. Okay, so yeah, so that's how we do the 600 roles. So that's what that is, just so you understand what this line does. Okay. Let's not print that right now. Next, we'll follow in the PowerPoint, right? You guys can probably, scoot ahead if you want, but I don't want you to. Values, right? And we also have frequencies. Remember what I'm doing, I'm taking two variables and I'm unpacking something like numpy unique. Numpy unique. And I'm taking the roles as input. That's a list, right? Or an array. And I'm going to put a return counts equals to true. Okay, so true, capital T. True. And what this does is it's going to take numpy. We're going to use numpy, right? We're going to use the unique method that's tied into numpy. We're going to pass in roles, right, which is a list. But what it's going to try and return to us is something called an ND array. It's actually a very efficient, much more efficient kind of a structure than a list is what it's going to return to us. So that's what's going to return here inside of values, right? So that's what's going to be the, kind of an ND array. And then we're also going to have a the number of counts. That's going to be the frequency. So counts is the second part of the tuple, right? It's going to return a tuple or a tuple. This is a tuple. It's going to unpack what we get from MP unique, right? And it's going to put one value inside values and the other value inside frequencies. That's what this is going to do. Okay. So that's the second part. And what we want to do is let's print out those and see what those are. So if I say print roles now, you're not going to see much of a difference. If I do Python bar plot, it's the same, right? Same kind of thing. There's not much, it doesn't look different. It's just from if I hover over now, you can see it just returned. This is a list, right? And let's do values. Okay, so if I hover over values, as an example, right? I'm not getting really anything back from it. But if I was going to go to this, you're going to see if I'm getting the values are 1, 2, 3, 4, 5, 6. So what it's doing is taking the unique values from this entire list of roles, unique. And you can see that the unique values are 1, 2, 3, 4, 5, 6. There isn't all this. This is all the distribution. This is all the data, but there's only 6 unique values. Okay? So that's what values are, the unique values, right? And then frequencies, if we try and kind of look at frequencies, that will give us the counts per value, right? So it's another ND array, right? So let's say look at that. You can see here's the other ND array, 107, 109, 91, 91, 104. You can see again that these aren't exactly equal. Let's print them both. So if I say print, we'll use the F string. So we'll say that values, right? And we'll kind of inject values here. and we'll also do comma, and then we'll do frequencies, and we'll inject frequencies. These are all things we've learned how to do. Okay, so at this point you should know how to do, if I can type properly though, you should know how to interpolate with Python. You know, as an example, you should be able to do those things. So if I was to do this and go Python bar plot, then you're going to see the same thing, 1, 2, 3, 4, 5, 6, and then the frequencies are 102, 106, 92. Now remember that we're getting different frequencies because we're getting different counts, right? We're getting a different counts, and if we want the same amount all the time, how would we do it? What if I want to get, I want to reproduce, I want to make it reproducible. How do I do reproducible? We talked about this with random. How do I do it, guys? Anyone can use the chat to answer this question. This could be a test question, like a quiz question. How do I do reproducible results if I'm using random numbers? There's a way. I talked about it in a previous lecture. Random seed, yes, that's the way. Right, so we're going to say that before we do our random numbers, we can seed it. We can say random.seed, and we can put in a number, any number. Let's use the number 45 as an example. Okay. So again, I'm just using the number 45, not for any other reason. I'm going to save this and then see what happens if I do it again. So you see that I got this distribution: 90, 93, 101, 104, 102, 110. Right. That's the distribution of frequencies. And then if I was to do it again, you're going to see I'm going to get the exact same distribution this time. So now I can test to see that the distribution of frequencies is the same all the time. So we can do some testing of our number ranges, and that's why we call reproducibility. We use a random number seed for that, like we talked about in the previous lesson. Okay, we use different numbers, different number seed, and then we can always look at the numbers. So let's do this test. I want to also look at the roles. If I want to look at the roles, right, I can also do that at the same time. So then let's look at what that looks like. So this is the number of roles: 3, 4, 4. Look at these numbers: 3, 4, 4, 3, 1, 1, 3, 3. And if I was to roll it again, it's going to be the exact same numbers: 3, 4, 4, 3, 1, 3, 3. See? That's just proof for you. So that's how it works. I don't always want to see these numbers. That could be really long to print. So I'm just going to delete these things. Okay. So this is our first part. So first we want to make it reproducible. I'm using the number 45. You should get roughly the same result as me. Okay. So do you get the same result if you use the 45 as a random number seed? What do you guys get if you try and do what I've just done? What is are you getting? Yes, the same, right? So think about that. You and I are both getting the same results. That's really testable. That means if I give you a data set and I give you a random number seed and I say these are the results you should get based on this data set, we can analyze that data set together. And that's why we do it that way. Okay, so the next part. What we want to do now is we want to start setting up our bar plot. All right, so we'll keep this and we'll say I want to kind of set up and configure our bar plot. That's the next part. So we're starting to configure it. All right. So the first thing is I want to set up a title. So my title is going to be an F string. You can use F like this, right? Which is rolling a 6-sided die, right? And we'll give it some space, something like this, die, with a length of, remember length is a built-in function, roles, right? The length of roles is what we want, and then colon, comma, and what this will do is it'll do comma separated. So it'll do a length of roll, and it'll inject kind of all the roles in here, right? Times. So comma separated, and then it's times like this, right? A couple of lines like this. Okay, so that's kind of our title, and then we want to start off with Seabourn. Okay, so here's our Seabourn. So we're going to say something like, "Hey Seabourn," remember SNS is Seabourn, dot, let's set style. We're going to kind of set up the style for our chart, and we're going to set the style to a white grid. All right. Now, as I've said in here, a couple things, right? So we're using comma separated values for our roles, length of roles. We're using comma separated. And then what we're doing is, so that means if the roles become large, right, the number, the frequency, right, as an example, it'll separate the numbers into, if it goes beyond 6, in the thousands, it'll say 6,000 with a comma, 6, 000. Millions, it'll do, 6, 000, 000. That's what this does, all right? So that's what it does. We may have to give a bit of more space. I've just given some space here according to the plan, all right? So it's thousands separators what it is, right? And we have some options. So right now, what we're going to say is, by default, Seabourn produces a white background, but a white grid basically kind of layers in a light gray, like horizontal lines that we can see, so we can separate our vertical plot. Okay, that's what it does. So that is what Seabourn does for us. Okay? And so this doesn't do anything at this point. Okay, so just to show you this. So Seabourn, remember Seabourn is using matplotlib. That's what it does. And if I was to run this right now, right, if I said bar plot, right, it does the frequencies, it runs through it, and then it does nothing, right? So remember, if you want to run it, and it says it right here inside of our code, if you go in here to these lines of code that I want you guys to put in. So I set a couple things. I set the style, and what we want to do now is we want to set the next thing up, which is the axis. Okay, so that's the next part we want to set up. Okay, axis. So axis is the axis for the bar plot. All right, let's try this next part. All right, I've already done up to here, and this is page 15 so far, if you're following along. And I'll check with you in a second when we start producing the bar plot. All right, so going back to that, that's the next part we want to put in. We want to put in axis, right? And we want to say that the axis is so Seabourn, hey Seabourn, we're saying hey Seabourn, bar plot. We want to plot out a bar plot with x equals to values, right? Y is equal to frequencies, all right? So we're just telling it the x and y labels, right? And then we're going to say palette, right, which we can choose to use something called bright. All right, now you can use, we're going to try other palettes too, but our palette is going to be the bright palette. And if you guys are interested, there's I've put it in the PowerPoint that there's a lot of different options for the palette of colors that you can use to kind of support different distributions of colors along the bar charts. And this is just one palette that you can use. Okay, and there's many others. So it's not going to do anything yet. So even if I come up to here and if I run this thing, right, you're going to see it. It does set things up, but it doesn't actually do anything. And again, going back to PowerPoint, it warns you. It's kind of saying, hey, we need to use plot.show in order for us to do anything at all. So if I was to try and see the bar plot, I need to do plot.show. And what plot.show is, if we did everything right, and maybe we didn't, but if we did everything right, then you should see this. So now, let's see, using the same distribution, you guys should have a very basic bar plot that looks like this now. Are you with me? I want to see check marks for sure now, right? Because this is, if you don't have this, then, and Rude's with me, all right? Tiago is a no, all right? Tiago, are you having trouble? Is that why you're not with me, or you need more time? So this is kind of cool. I mean, I think that, look, we're able to see distributions. We don't see numbers right now, okay? But we do see distributions in our chart. And this is kind of a really cool thing. Guys, I'm waiting to see some check marks if you guys are following along, because I want to make sure that you guys are good, right? I don't want to move on until it didn't come out, trying to figure out why. Are you, Tiago, if you're using Ubuntu or using Fedora? Fedora. Take a look at the visualization to actually you have to do a little bit of Googling on that one. That's why I like Ubuntu, because as soon as I do it, I got all my stuff in a row. It just does the work. I didn't do any additional installations besides the ones you saw, right? But one thing I noticed whenever I use Ubuntu, I have less trouble with visualizations than I do with Fedora. So that's why I've recommended Ubuntu to you in the first place. I think it's an easier way of doing things. But you shouldn't have a problem with Fedora either. Try, maybe there might be a Google step you have to make. You forgot to save it. Okay, cool. All right, but now you're good. How about the rest of you guys? How about Steve? How are we doing with Joseph? The regular bunch of guys. Shankar, are you okay? Other than Tiago and Anirudh? How are we doing, guys? I want to make sure you guys are okay. Shankar's good. Steve's having trouble. Steve, what's the problem? The same as Tiago? It's not printing for you? Or just taking too much time? Some error. Okay. And are you using Fedora or Ubuntu? Because that's kind of a thing. Fedora, yeah. So again, you may have to install. There might be something you're missing from an installation perspective, and that's always an issue I always found with using Fedora compared to using something like Ubuntu. Ubuntu is cool because, and I kind of like to do it side by side when I'm in this mode. Again, you can use side by side. Remember that if I do one of these with command and left, and then if I do kind of this one, command and right, it'll actually grow the bar chart so it's equal, like this, right? One thing that when you do have your bar chart up, had some storage space issues with Pip Install, so I'm making Ubuntu VM right now. Okay, no problem. Go ahead, do what you have to do. Great thing is I am recording this, so if I ask you to do something like this in the future, then you should be okay. Okay, you should be okay. So again, notice we have another little window that comes up, and you can see that I have some control. So if I want to change my different values, now the reason why this isn't changing is because I've maximized this thing, right? So that's why nothing's happening, but it tells you the value. So if I kind of go here and double click, right, like this, and then if I go open up these little controls, then it should allow me to change the width and so on of these things. And by the way, you can also do this programmatically if you want to see it this thin. You can change some of the options in Seabourn or in Matplotlib. All right, so we've got everything going, and let me just do this one more time. So I want to run this one more time. So Control backtick, and I want to clear the screen, and I want to run Python bar plot, and it's going to do the bar plot. Yay, awesome. And if you notice, there's a little symbol here for save, and what I may get you to do in assignment number 4 is if you click on this little symbol here, you can save your file as a PNG, right? So this is kind of proving out that your bar plot is working, right? So so let's say we'll put it in our downloads, all right, and we'll store it figure1.png. We can also call this, you know, bar plot 1 or whatever, but figure 1 is okay because we're not really doing much with it. So if I say save and save it, and then if I go to my you know, file explorer, right, so let's say do the same thing, and I look at my downloads, and you can see that there's figure 1. There it is. So if I double click on that, we should be able to visualize that right here, right, with image viewer. Okay, that's pretty cool. So we have access to this later on if we want to include this in, let's say, a Google Slides deck or a PowerPoint document or something else. All right, so that's how we do it, and that's how you get the output manually. You can also do it through code, which we're going to learn how to do later on. Notice also that because I'm running, it says extensions want to make the following changes to the terminal's environment. You you know, and it's not, it says VS Code, get ASPass, and blah, 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 right? And it says relaunch terminal if I want to make those changes happen, right? So notice that that closed down when I did that. Let's try this again. So I want to do a, oh yeah, I lost my stuff. I'll say Python, and I want to do bar plot.py, and then it'll come up again. Now I don't have that error anymore. Cool. So I think by now you guys should be closer to having things done. So how are we doing? Steve, are you still having trouble? Are you better? How are we doing, guys? Palette has only one out. Yeah, that's that. There you go. Okay, so Steve, you're good. I'm hoping everyone else is good too, the people who are following along. I'm going to move on now. All right, so cool. So as soon as we do this, we've got our little bar plot. I think it's kind of a mission accomplished for me, because once we were able to get to there, I mean, we got a data set, right? That's what we've got. We've generated our data set for us, right? That's what we've done here. Generated our data set. And when we generate our data set, we generate a number between 1 and 600 times. That's what we're doing. And we're storing it in a list of rules. We're using MP unique to split values, which are our numbers between 1 to 6. Those are the unique values, which helps us make our chart, right? So that's what we're doing here. When we make our title, we're getting, first of all, a bunch of things. The title for the chart, this, as an example, you know, we haven't really used yet, right? So if you notice on our PowerPoint, we set up our title, right? But we haven't used it as of yet. All we've done right now, we made it, right? And we set up our roles, right? So we should have this kind of graph again, which is what we're looking at, okay? One thing I do here is I go through and we talk about things like what the palette is. And if you actually click on this link, so if I press Control click on the link, it'll give you different color palettes that you can use, right? And there's different ones you can choose, right? So we've used bright, that's the bright. There's also muted, deep, pastel, dark, different kind of color palettes that you can go through. And I think this is a good exercise, and it gives you some more ideas on how to do stuff. Palette plot, you can do that, and see different kind of color palettes. You can also make your own color palettes. There's custom palettes you can create as well. All right, you can do things with categorical that make sense, and so on. So they're kind of paired together. So colors that are similar. That's what the paired is. So blues, greens, reds, oranges, and so on, right? And there's a bunch of other options that make it really cool, like a bunch of different colors of blue, you know. And again, you might think, who cares, Tom? This is like, it's nice, it looks nice, but who cares? But actually, when it comes to presentation, a lot of times when you want to present your findings to someone, you want to present them and you want them to look nice. You can also do all kinds of different kinds of plots that it'll do for you. The tools that we're talking about right now, we're really starting with this high level stuff, but it can do really awesome visualizations, you know, based on, of course, on our data, right? On our data types. We're going to get there slowly, but this is just us plotting and using the tools. That's all we're doing here. Okay, so I just wanted to indicate that link is inside the PowerPoint. All right, so let's go back to this. So we did this part, and it talks about the axis object we configured, right? And the axis object creates, you know, kind of the axis in our bar plot. That's what we're doing. Let's add some additional things. So we're going to set the title finally. We're going to use these next pieces of code. A couple things to note. Whenever we see some of these things that I've pasted in here, you see this thing called out and in. This is using IPython, or you could also, you know, use Anaconda, and you'll get something similar to this. We're not using Anaconda. We're doing things with code, so we really don't care about the out. Out for us is like what the expected output should be, right? That's what we're thinking, right, when we do access. And the same thing goes here. What's the expected output for this one, as an example, right? So let's do this thing. Let's start setting up this additional information. So again, going back to ORVM, right? And this is just stepping through how to do this kind of stuff, so that way we can have success if I give you something more important to do. All right. So let's not do plot show yet. Plot show is like the last step. So what this does is it displays the bar plot, or any plot for that matter. This is just in our case what it does, right? Displays our bar plot. So we want to say, hey axis, let's take a look at, let's set the title. So notice that we're not getting any code hinting for this, which is not a happy thing for me. So axis, set title, and we want to set the title to title. All right, let's do one thing at a time. Let's see what happens now when we run plot.show. So if I go something like, hey, let's run it. Hey, there it is, rolling a 6-sided die 600 times. Notice that the title, right, rolling a 600 die, right, space, and then 600 times, that spacing, if I was going to make 1,000,000 times, that may not give us enough space in there for the 1,000,000, right? So if I add, let's add some more spaces in there, because you want to kind of adjust it so it can space in that as well. So if I do this again, you can see now it's going to have more spaces in there for the amount of times we're going to use. Okay. And let's do the next part. Let's do the next one. So we've done this one, and that's what this does. It actually does the title. So sets the title for the axis on the top. Then what we want to do is we want to say axis.set, right? And we want to set the X label. So X label is equal to the die value. We're going to set this up for ourselves. And the Y label is equal to the frequency. All right, so that is the X and Y label. That'll actually put X and Y labels on our chart. So what this is doing is, I'm going to put this in there so we can see this. This is labeling the bar plot or chart. All right, that's what it does. This is all the labels we need. So this part is the setup. This gives us our style, right? This is our title, right, for the top. But this is, kind of labeling the axes, right? Axes, and that's including the top, right? The title and so on. Really, if you think about this, this could have been done anytime. As soon as we set up axes, we could put this one over there, but this is kind of labeling the axis. And if I run it again now, Python bar plot, then you can see now that we have a couple things. We have our frequency there, our die value there, right? Just like we would normally do. Again, we're doing this all in code. If we were going to use something like Excel, which is awesome, right? Then it'd be similar, right? We would put a frequency there, or make a chart, die value there, and kind of a chart title is what this is up here, right? All right. So that's what set title does, and what the set method does. Set method receives X label and Y labels, and there's other things that can also, different kind of keywords it can accept as well, and that's what we should do. We have the bar plot that we have so far. Okay, are you with me? Let's get to that point. Okay, I see a couple of check marks now. Tiago and Steve. Steve, you fixed your problem. Looks like that's good. Anirudh, looks like good. How about the rest of you guys? Shankar, anybody? Shankar was with us earlier. Is he still with us? He's with us. All right, cool. So how about Vaisal? Vaisal, I saw you kind of were with us at one point, but now no longer. I haven't seen you kind of follow along for a while. All right, so what I want to do is I want to set we're going to do some additional things here. So we set the frequency and everything else, and what we can do is we can set there is something called set Y limit. Set has a bunch of options. Axes actually has a ton of options, right? And so sometimes I want to set a Y limit. So axes dot, and I want to use set Y lim, and inside set Y lim, we're going to put in our top That's an option. Top is going to be max frequencies. It's the maximum of the frequencies, right? And we're going to multiply it by 1.10. Okay, so what this does is says this is our y limit. Y limit is the maximum value. The top of this option, y limit, is the maximum value of the frequencies. How many times things got nailed, right? And like the counts, almost. That's the counts, and then multiply by 1.10. And what this is, it's going to make room for the text above the bars based on that 10%. I'm actually reducing the 1.10, actually reduces the number. I want to make it so we're saying that the largest frequency, we're multiplying it by 1.10 to ensure that the y-axis is 10% taller than the tallest bar, right? And the reason why we want to do the y limit is the y-axis. I want to move the y-axis line above the bars. Otherwise, what's going to happen, the bars are going to climb too high, and it's going to make the chart look kind of messed up. Okay, so that's what this does. So again, I haven't done anything else. Let's just try this and see if it works. One thing at a time. So that's what's happened. So you see now that when we put it in there, we've got a little bit more space on the top, right? If I took that out as an example, and let's get back there. Sorry, I know that I'm doing it kind of backwards, but I want to make sure that you guys are good. And if you notice, I take it out. See how there's less space and the numbers go to 100, right? But if I put it back in, oops, I didn't put it back in. If I put it back in, then it goes to 120, right? So it's like 10% more, the y-axis is 10% more than the maximum value of frequency. So these are the frequency counts, right? Frequencies. So out of 100, they should all be 100, but you see brown gets more love than the other ones. Brown is 6. The number 6 was rolled in our distribution because we used 45 random number seed. In our distribution, 6 was rolled more than others. And so if you use the same random distribution as me, this is why it's great for testing. You should see the exact same bar chart as I do. The exact same. No problem. Thanks, Faisal. I got your message. All right, so it makes sense, right? It makes sense that what this is happening. So this is what this does. It puts that a little bit higher than everything else. Cool, cool. All right, the next part, what we want to put in. Now this part is a little longer, so you're gonna have to bear with me while we do this part together, right? And I'm not gonna copy paste. I'm just like literally I'm gonna again push plot.show is the last thing we do. All right. So again, this labels the axis. Let's rejig some of this. I want to say that all of this, so axis. And let me just turn off formatting for a second. It's not letting me do my thing. But really, the title could be put right here. So really, once we make the this kind of sets up the style or whatever. Y limit kind of sets up the labels and I guess the axis, labeling the axis for bar plot. So bar plot axis, and sets up the Y limit. That's what this does. Okay, now this part is something new. So I'm going to say, okay, for bar and frequency, so frequency in zip, and we're going to talk about what zip is in a second, in zip axis dot patches and frequencies. All right, so we got a bunch of new things here. Let's talk about what these are. All right. All right. So first of all, zip. What is zip? Which is, it really does. We use a for statement and we use zip, which is an iterator. That's what it is, to iterate through something called patches. And patches is really a collection of two-dimensional colored shapes that represents the bar plots, the plots bars. That's what it is, right? That's what patches are. So each of the patches in the axis is each of the bar colors. That's what those are, okay? So zip, what it does is it unpacks, right, the patches and the frequencies, and then basically what we're going to do is for every bar, it's going to take whatever the patch is and it's going to put it inside that bar argument. And the frequencies that we're going to get, which is the frequencies for each of the bars, right? So the color and the frequencies for each of the bars, and we're going to kind of put it into the color is going to go into bar, and the frequencies is going to go into frequency for each object inside of the bar plot. That's what it does. Okay, so that's where it's going to do those kind of things. Okay, so then we want to start thinking about our text on the x-axis, text on the y-axis, and a bunch of other things we're going to configure. Let's start configuring. This is the most complex piece. So I'm going to say text x, right? That's a new variable. So a new temporary variable, text x, as an example, is bar.get, okay? And we're going to get x. We're going to get x from the bar. So remember, each bar represents the actual bar, the red bar, the blue bar, all those kind of things, right? Plus, we're going to get bar.getWidth, whatever the width of the bar is, right? And then we're going to divide it by 2. You can also multiply it by 0.5. If I was going to do a video game, I would multiply it by 0.5 because dividing is not as efficient. So that's the first text, the text x. And what does text x do? I'm going to go very, very slow because there's a lot of stuff going on here. Okay. So it's almost like the center x coordinate where the text is going to appear. That's what text x is, the center text coordinate. All right. For where it's going to happen, and then we're going to calculate this value based as the bars, the sum of the bars left edge coordinate, whatever the left edge coordinate is. So again, we're just actually adjusting the bars, kind of the way the bar works, right? Each bar we're talking about, each colored bar is what's happening here. The left edge x coordinate, that's what bar get x is, the left coordinate, right? And then half of the bar's width. We're adding those two together to get the middle of the bar. So this calculates the center of each bar. Okay? That's to give you a sense of what that is. Next one. So now we're going to say text y, right? And we're going to say bar.getHeight. Okay, now that's what this does. All right, so we're going to get the height of the bar. That's what the text y is. And I just want to make sure I got everything correctly for you. So it's the y coordinate where the text will appear, right? So that's where I want the text to appear, right? The height of the bar, all right? So y coordinate where the text will appear, okay? This is the x coordinate, right? Where the text will appear. And it calculates the center of each bar. This is the top of each bar. That's what happens, the bar height, right? And then I want to actually put the text in. So I'm actually putting this thing here puts the text in the top of each bar, right? So then I'm going to say text itself, the text of each bar is equal to a f string. We can do that, an f string, where we're going to inject frequency. The frequency we're going to get for each bar, this frequency here, not the frequencies for all the bars, because we've unpacked each of the frequencies. Frequencies, remember, going up to the top here, frequencies is a list of frequencies, or an array of frequencies that we got from Numpy. Numpy basically says, hey, count all of them, put the total counts, which is the almost like a tally of frequencies. That's what we put in frequencies. Values is 1 to 6. Frequencies is how many? How many times does 1 or 2 or 3 or whatever hit? That's what frequencies is. And we're going to say for every frequency in frequencies, because basically there's different frequencies for each bar. So for each bar, take the frequency for that bar, right? And that's what we're looking at there. We're going to use that as a title for each of the bars, right? So frequency is something we're going to put in. And what we're going to do is we're going to use commas. Again, comma, what this does is if the frequencies go beyond 1,000 and in larger numbers, when we change these values, instead of 600, we go to 600,000 or 6 million or whatever it's going to be. That's a different thing, right? And then I want to \n. So I want to say, hey, go to the new line, right? And let's not add a space in there. New line. And I want to inject frequency again, right? Divided by, and this is the percentage. So underneath the frequency, we're going to put the percentage of the number of rolls that we made, right? Okay. And it's going to add in with a precision of 3 decimal places. Okay, that's what it does. 3 decimal places is what we're looking at from a precision perspective. This is just all formatting. So again, there's 2 things I'm asking for each bar to have. The frequency at the top, and underneath the frequency there's going to be the percentage, right, which is the distribution percentage. That's what it's going to be, okay? If that makes sense. So that's this part. This is will print the frequency and distribution for each bar. That's what this does. Okay, I'm gonna let's just space these out so that all the comments are over here, so they're together, so that it doesn't confuse you. Again, we're just using inline comments here so that you can see what's happening for each of these things. So this is confusing. If you've never seen it before, you're like, wait, what's going on here, right? Okay, and then once we've configured the text, right, that's configuration. Then what we're going to do is we're going to say axis.text, and axis.text, it does the text for each bar. So for each bar, then we're going to use text x as the x coordinate and text y as the y coordinate for where we're going to put the text. And then what text we're going to use is this. So that's the text we're going to put in, right? And then we can configure some other things, like, for example, font size. We're going to choose 11. That seems to be the right number. And then we're going to see horizontal, right, alignment. That's what that stands for. Horizontal alignment is center, as well as vertical alignment is going to be bottom. Okay, vertical alignment bottom. So it's going to put the text object, it's going to kind of push it down. We can change some of these values to see what the effect is going to be. So this actually sets up the text. So this prints this, shows the text. Show the text for each bar. Okay, so this is kind of sets up the text. That's what this does, and this. Just want to make sure that this is all good. I'm going to put this up on GitHub for you guys, right? So remember that this is going to be up there, so you have an example of this, and we'll make this into a function in a second, which is going to something that I can call in main.py. So I can say, hey, main.py, call this function, and it'll do the stuff for us, right? Which is what we want. Okay, so that's kind of the limit of what we want to do. Let's see what it does now. I'm going to give some space in here because we might have some other options we want to put in. Okay. So again, I want to do Python bar plot, and then if we did things correctly, you're going to see something that looks like this, and it should be similar to what we've seen inside of the of our distribution here. See, this is what the final bar chart. This is the last page of the PowerPoint. This is kind of what we're getting right here for 600 times, right? Are you with me on this? This is what yours should look like. If you're using the distribution where we're saying the random seed is 45, right, then yours should look like this. Okay, yours should be like mine. Are you with me? I got some people that are saying yes, and some other people are not answering because they're still looking or whatever. Excellent. Now see that? This is a great thing for us, right? So think about we're analyzing a data set and we're doing some comparison. We're having a discussion. Thank you for that, guys. We're doing a discussion. Let's say, suppose we're data scientists. We're not data scientists right now, but let's suppose we are for a second. We're having a discussion about the data that we're looking at, and the data tells us a picture, right? It paints us a picture. It tells us a story, if you will. So what's the story that we're getting from this data right now? That somehow our die is imbalanced. That, you know, we're rolling the same die, and most times we're going to get a 6. If I was going to play Dungeons and Dragons, this would be a great die. I would like to use this die because I'm going to get 6 more often than anything else, right? Now it's not a great deal more, but the distribution is slightly higher for 6s being rolled than 1s, as an example. In fact, it looks like it's a nice distribution so that I get the higher numbers. 4, 5, and 6. Actually, well, maybe 3 is kind of as good as slightly lower than 4. But 4, 5, and 6 are the highest numbers I'm going to get every single time. If I had a die like this, if I had 3 dice like this, whew, I'm going to have luck in Dungeons and Dragons. A lot of good luck when it comes to rolling my character or doing other things, like doing damage, as an example, right? So that's cool. Let's change the numbers. Let's try the numbers different. So let's try a different set of numbers. Let's try, instead of random seed number 45, let's try the number 23, and then we'll try the number 42, just because. You know, so we're going to try this out, and you can see now the distribution is different. If you tried number 23, you're going to get the exact same distribution as me, right? So 109, see that now in this case, we're getting this kind of distribution. Again, it tells us a story, right? This is just a 6-sided die, rolling 600 times. Okay, cool. And one more time, we'll try the number 42. Right, which is kind of an answer to everything, right? And we try this out, and all of a sudden, boom, we've got this interesting number, right? That, you know, again, a different distribution. This is really bad for number 4. 4 seems to be almost, you know, coming up a lot less, you know, than everything else. And whereas we have some good distribution for 1, 2, and 6, the rest are kind of a little lower. And where 5 is exactly where it should be. 5 is the exact average. It's 100 out of 600. It's 100. This is perfect for 5, but the rest is not good, right? So this is good. Let's put it back to 45 because we can see that now. Again, reproducibility, you know, gives us this kind of thing. These are static charts. Next week we'll do, if we can, we'll do dynamic charts, things that change on the fly, right, for us. This is back to where we were before. Okay. What about if you wanted higher numbers, right? I mean, we're trying some lower numbers as an example, and I want to try some bigger numbers, right, as an example, because, you know, we have you know, we have numbers that we want to do 60,000 times as an example instead of just 600 times. Let's try that one. So again, I'm going to stop this out, and let's go, instead of 600, let's go 60,000. So let's put a couple more zeros in there. This is 60,000 times now. And you're going to see how, with the same number, same distribution, 45, let's see what happens with our numbers. So I run it now at 60,000. You're going to see now it says die. So rolling a 6-sided die 60,000 times. And see that it put the comma in there, and it also put the commas in here. Those commas have been put in there because of where we do frequency : comma. It takes the frequency, whatever that number is, we inject in here, and we add a comma in there. That's what the comma does. It kind of separates the numbers with commas. Okay, so it's a little bit closer. You can see that. Look, 16.77, 16.66, 16.80, 16.84, 16.25, 16.40, 405. There's almost the same on all of them, really, right? If we had 60,000 roles, each one of them, 4 out of 5 of them had like 10,000 or around 10,000. All right, that's pretty good. That's a pretty good distribution for die roles. Okay, again, with the same random number seed. We haven't changed that. Okay, so that's 60,000. And we haven't changed anything. We haven't, done anything in terms of making our numbers different, right? We haven't changed our numbers at all, right? So what about if I wanted to make it 6 million, right? How do I do 6 million? Do you guys remember how to do that? Can I just put in 6 million? Right? Let's try this out. So what if I want to make it 6 million now. So I want to say 6,000,000, 6 million. So I want to do 6 million times, not 60,000 times. And if I ran that, kind of thing, and I want to run 6 million times, it takes me a second to do, right? Here's 6 million. Look, it did, even for my computer, it took me a bit of time, right? You can see the distribution. Here's the frequencies that we print out first. 1, 2, 3, 4, 5, 6 is the values. Frequencies is 999. And you can see that now they're way closer to where they should be. Remember the law of large numbers makes it so the more times you roll, it doesn't matter about the distribution. We can change this number to something else. They'll be slightly different, right? Relatively, you can see that 6 is a good number to roll still in our random number seed, but for the most part, the numbers are pretty good. Okay, let's try an even bigger number. Let's try something insane, right? Let's try something like 60 million. All right, so because we're trying different numbers, let's try 60 million and see how long that takes to do. Does it even do 60 million, right? And you can see it takes a bit of time to get larger numbers happening. It's doing the calculation, collating the data, and will it break my code, right? Because remember, there's going to be a limit to how big it can be. 60 million, well, that's a lot bigger than 6 million, and it's doing the tallies a bunch of times over and over again. See, it's still going. For you, it might take a while as well, if it does it at all. Yay, 60 million. But now we have a problem, right? We have a problem with our distributions, right? See how the charts, it makes it so that it's hard to see the numbers because they're about 10 million each, right? That's how approximately it should be. Now notice the numbers are really close to the same now. Really, really close to the same. Okay. By the way, this is using 10% more to give us a chance to put this into the the dice, right? So we can see these numbers. If I didn't use 10% more, which is, I'm going to stop this now. So if I go to 1.10, we can use another number. Let's put 20% more to give us some more headroom. Okay, that's what this does, 20% more. And that's the Y limit for axes, right? So remember, axes has a bunch of stuff, right? Axes. And if I put set, and if I look at the axes for, and this is Seabourn, right, that we're looking at. So let's take a look at our documentation for a second. I'm just going to pull up documentation for Seabourn. So Seabourn documentation, right? And here's some stuff that you can do. Statistical data visualization is what Seabourn does for us, right? They have some tutorials that you can follow as well. Some really cool stuff for multi-plot grids that want to plot multiple things at once. How to do that. Different kinds of grids, but here we're doing some kind of bar graphs, right, for categorical kind of data, and there's color palettes down here. So, so they talk about set, how we can do set ticks and color, right? You can do, distributions that look like dots instead of bars. You can also do things like, box plots. That's what these are, which are really cool. That gives us kind of, a error distribution as well as outliers. These are outliers way out here outside of the fences, the upper fence and the lower fence, right? There's our, these are the bar and whiskers plot also is what it's called, a whiskers plot. So these are the whiskers right here, right? and you can see some outliers outside of the outer fence, right? And so it does all those kind of really cool things. It can do a lot of different kind of distributions, and we can set that up. There's all these can be set up, and they have the code for them here in Python, right? So you can see cat plot. It talks about how to do different kinds of plots, right? Based on what you want. If you want diamonds, if you want different kinds of the plot, the bar chart to go to the right instead of the left, different kinds of lines. Like there's a ton of things that the Seabourn can do for us, and this is just bar plots, right, that it can do. So really cool stuff. So what we want to do is we want to get the axis. So if I said, to get more specific, so I can say something like Seaborn axes documentation, right? So figure aesthetics is what it's going to go to. Here's figure aesthetics, right? And so set, and let's keep going down here until we can see we can remove the axes spine if you want to, which is this part right here, axes spines, and setting figure style. Here's a different kind of things you can do. Style white grid is what we used, right? And it gives us examples here on how to do all this stuff. So Seabourn, it uses something called a with statement, where we can, it's like a iterator that goes through stuff. But again, if you want to see all the parameters are included on axis, you can say axis.style, and there's grid, axis below, label, and you can see that there are a bunch of different things that you can do with the axis. All right, splines, Y tick, X tick, a bunch of stuff. Like there's so many things to do, in my opinion. Sometimes when I'm doing a chart or something like this, I remember when I was learning machine learning, it was daunting. It was like, oh my god, like how many options do I have? I have a crazy amount of options here. Which one do I choose? And you know what I did? I Googled it, and I was like, that looks good. I like that. Let's use that, kind of thing. As opposed to, because there's just so many options, but that you can see here, right? So again, if I was to look at the exact code that we have, which is axis set Y limit. So if I did that, axis set Y limit, and this is the bar plot axis that we're getting here, right? So if I go back to, am I messing things up? I am. If I go back to, if I said, Seabourn axis Y limit, right? So I want to control how to set the X axis for Seabourn plot, right? Or the Y axis, it says here. Then it gives some examples here. Y-lim is something that you can do. Set Y-lim to whatever you want, the Y limit. You can set it as an example. What about the X limit? Is there something like that for X limit? So axis.set Y limit, that's another way of doing it. You can actually use axis.set or set Y limit, right? So let's try that out. Let's play around and see if we can do something similar to the X limit. So if I said something like the same, so let's say I want the width of things. So I said axis dot set, let's try X limit if it's such a thing, and I want to say that the what does it do? First of all, what is the set X limit do? Let's see if we can get that documentation so we don't make a mistake. So Seaborn set, I think it's xlim, if it is even a thing. Xlim. Just want to make sure that it's correct, that I got the right thing, because there's ylim, and I think you can do xlim the exact same way. I'm not getting any code hinting, which always bugs me, so I can't I can't remember how to do it properly, and I don't want to break everything. Well, here's xlim. So it does xlim. That's for sure, right? So that's what it allows me to do. So I can probably do something like, let's say if I said something like I set my x limit to the right, we'll say is something like 500, right? Let's see what that does for us if we're going to set the x limit to 500. Save. I don't think it's going to do much right now in terms of what it does, but let's just see. Yeah, we should probably reduce the counts here for a second. Let me just undo that calculation. That was big. That's 60 million. Let's go down to something that's more palatable. Let's go down to something quicker, like 6,000. Not even 60,000, 6,000. All right. That should be much quicker, right, to calculate. Yeah. Okay, so that's what it does. So what it did was this x limit 500, right, as an example, didn't really give us a this is the actual limit of the number, right? And top is the maximum frequencies. That's the top, right? But right, and what about if we said something like 5,000? Something crazy, right? It's like way higher. Let's try that out and see how that works and see what it does for us. If it does what we think it does going to do, and it's actually not good, right? So 5,000 really doesn't do much. This is the die value, and it compresses everything else up here. So x limit, and I use right. Let's use something like left and see what it does. Actually, if I just put a number in there like 5,000. And let's see how that works out. And if I did that, yeah, so it kind of plots it to the right. So, I mean, it's not a great amount of things that I want to put in there. I wouldn't probably want to test anything there like this. Put this back. So this works the way it does, and it's pretty good. I wouldn't mind if we had more separation in there, and we're going to learn how to do that over the next little while. We also want to make them more adjustable as we go forward. All right, so again, you can see that there's a ton of things you can do here. One thing we can also do before we end for the day is I want to make this into a function. So again, I want to tie this all together, and I want to be able to call this function as an example. We don't need this anymore. But let's put this up on GitHub for you guys as is without it being a function, and then we'll add it as a function in main. Okay, so let's do that. So we're going to go to GitHub. We're going to say added bar plot. I could have done many more commits than this, obviously, but we're not doing more than one. I'll push this to GitHub for our repository for this week. So if you couldn't follow along, or your code looks different than mine, or something else, you can always look at GitHub now, and it has everything here. But what we want to do is we have all these things. We have these different functions we used for the first day we were together this week, right? And I use counting, and I use these just the demos, right? So different kinds of things for tuples and lists, unpacking, all these things that we did today, and I call it counting. So instead of that, what I want is I want to make a function that's in bar plot, because this is a big function, right? And I like to separate this out. So what I want to do is I want to call this bar plot, right? So that's what it is, and it's really we should probably call it something that it is, right? Which is really what this does is it takes a simulation, a bar plot of the simulation of let's say 6-sided die, right? So almost like a 6-sided die bar plot, right? Okay, so we can say def 6-sided die bar plot. Okay, that's what it is. So now what we want to do is we want to kind of sub in, right? Again, I'm just tabbing in to each of these things so that I include everything inside of my function. Okay. Okay, so that's all that. Six-sided die bar plot. Okay, I've saved it. And as we did before, if I wanted to use it in main or another file, right? And again, this is kind of a contrived example, but I would do an import. All right, from bar plot, right? I want to import something from bar plot. From bar plot. Import, right, this six-sided die bar plot, and we can make it as something else, like some kind of smaller thing, like, you know, a D6 plot, right? Okay, so that's what it is. So D6 plot is six-sided die bar plot, and what I can do is I can say that, hey, let's call that D6 plot here. Right? And if I did everything correctly, then this will import the other file, bar plot, in here and run that and ignore all this stuff that we did earlier this week. Okay, and if I did that, let's run this and try it. So control backtick. I'm going to clear this one and just say something like Python main.py. And now this should do the exact same thing. Now notice what it does whenever I do this. It modifies, and it creates this thing called PyCache, but it still runs everything in the exact same distribution. Even if I did it again, right? Because we're still using 45 as a distribution. Now it would be nice if we could send some something to the plot instead of me hard coding how many, the 6,000 die rolls. It'd be nice if we had kind of a number that we could send in as a parameter. Let's do that. So again, what we want to try and do is go to barplot.py, and inside here we want to take a you know, kind of a number of rolls, right? Or you know, like a frequency that we want to use. So this is the range. Let's call it range. So we'll say range. Well, we'll just call number of rolls. Number of rolls. These are also called, by the way, episodes sometimes. How many episodes that I want. You know, again, depending on the data science. Number of rolls is what we want here. So number of rolls. So now we're going to have a number of rolls we can pass into our six-sided die bar plot, right? As opposed to a fixed number all the time. So that gives us makes it a little bit more, gives a little bit more utility, right? So in my main.py now, this isn't enough. I want to specify a number of rolls. So let's suppose I want to use a number of rolls like 6,000. We should get the same distribution out, right? So 6,000 and go here and main.py, and we should be able to get here 6,000 rolls. But if, let's say, I wanted 600, you know, as an example, then I should be able to go out and get 600 rolls. And this is the same distribution we saw last time, 600. Let's take one more step further. I want to take the random number seed as well. Give me the random number seed, but I want to make that as an option at the end. So the number of rolls and then the seed, but as a default, the seed is 45. So to do that, this is all functions again. We talked about that last week. I would go here and I would say, well, the number seed, right, is going to be equal to 45, right? And I'm going to pass seed in here, right, as a default. So if you don't specify the seed, it's going to give me a seed of 45, right? However, I can specify a different number, random number seed if I want, right? So again, if I go back to main.py, nothing changed. I can still run this the way it is, and we're still going to have the exact same distribution. However, if I don't like this and I want to try a different number, let's say you found that a different number looks nicer. Let's say, for example, the number 23. I can use this one as the seed instead of 45. And I can just do something that looks different, right? So more variability, I think, is the right way to call this, right? All right, and that's pretty cool. And also, I want to suppress some of this output, right? This output here, which is the values and the frequencies and all that stuff, that's not really required. You know, for what I'm going to get that in the chart, right? So in my bar plot, I'm just going to comment that out, right? So I think that's kind of the final piece for me, where I don't have that output, you know, kind of thing. It just shows me this. Okay, so that is the end for today. I'm just going to go back to what we did before. You can try different numbers here if you like 60,000 might be a really decent number with a 45 distribution. You can see now that it's pretty good, and you can store that by saving it. And we're going to do more of this next week. So that's it for me today. Let's put this up on GitHub. I'm going to say that I'm going to go here, right, and I'm going to go to, these are the things I added. I'm going to add these all to the changes I added in, right? Staged all these. I'm going to say, you know, added the six-sided die bar plot thing, which is what we did here, right? It's six-sided die bar plot function. Six-sided die bar plot function. Okay, so we did, and then push. So you should have everything that I have now at this point. All right, so lots of learnings today. I thought that it was we kind of accomplished what I wanted to do, which was, you know, go through a little visualization. We used some external libraries that we've never used before. We used Numpy, we used matplotlib, we used Seabourn. We also, you know, we're able to do some visualization, which is great, as opposed to seeing just like a console app. We're doing something that is more interesting, which is also something I want to do. And we're going to do more of that next week, right, as we hit more of the stuff that I want to do with you as we go forward. Okay, so next week I really want to get into some more things about dictionaries and sets, right? Because we talked about dictionaries at a very high level. I'm probably going to skip over dictionaries a little bit and get into more sets. Okay, I'll stop the lecture and we'll do that, Anubin, afterwards. And so we'll talk more about that. And then what I really want to talk about next week, if we can, if we have time, is let's talk about some, from a data science perspective, can we do more, you know, not just looking at sets and dictionaries, but I also want to do this dynamic visualization. How do I do dynamic visualization, and how does it work? And what do we need to get that dynamic visualization done? All right, so that's what we're going to be working on, as opposed to what we did today, which was static visualization. So again, intro to data science, but dynamic visualization next week. Okay. Otherwise, that's it for me this time around, guys. Thank you so much for attending, the people who came. I'm going to stop recording now, and I'll go to questions for those people, or people who had issues with installations.